Here's another Newton's first law question. This is the Eastern Cape 2020 exam. Now let's cut the chase. Now it says a pulley system is used to keep a crate of mass mkg stationary as shown in the diagram below. This is the crate of mass mkg. We're not given the mass, is kept by the pulley system. So there's a rope that is attached to this that kept it stationary. So this tension force it's 243, and this tension force it's T is just T1. This is T2 and T3. We're not given that. And there's a force that is acting, which is the gravitational force. So the force that is downwards here, the downward force is the gravitational force. Now it says define the term resultant vector. The term resultant vector, it's a single vector that has the same effect of the other two vectors. Check the exam guideline when it comes to a resultant vector. Now guys, what I want to do first, I want you to show you the forces that are acting here. Um, if you can draw the vector diagram of this, you the vector diagram. Okay, let's start with the free body diagram. The free body diagram of the forces that are acting on the crate, it's going to be the gravitational force, and it's going to be T1 in this direction, and then it's going to be T2 in that direction. Those are the forces that are acting here. Right now, in order to draw the vector diagram, drawing the vector diagram of this, you have the tension force, which is this is T2, and the gravitational force. You draw all these forces consecutively, these forces. So I started with this one, I'm gonna go with this way. Right, so I have the gravitational force that is going downwards, which is Fg. And then I have the T1 that is going in that direction. So it's T1, right? So guys, now we are given this is will form the right angle triangle. So we are given the angle here. It's like you're drawing these forces here. Here's the T1 going in that direction, and then here's the gravitational force. So you have the angle there, it's 30, and then it's 30 plus 90, it's 120. That one is 60 there, right? So that's the vector diagram of that. So let's answer the questions now. In question 2.2.1, it says calculate the vertical and the horizontal component. Vertical and horizontal component of T2. So the T2 force, if you're looking at the T2 force, it's a force that is at an angle. You see the T2, that's the force. So it has the horizontal and the vertical component. So the horizontal component, it will be like that. It's going to be T2x, and it's going to be this one is going to be T2y, right? Those are the components of that. So answering the question here in 2.2.1, the vertical component first, it's T2y equal to T sine theta. So the T is this force. So it's going to be 245 sine, what is the angle? The angle here, it's what? It's 30, this angle. So it's like you are halving the 245. So 245 times by half. It's 122.5 newtons. What is the direction? It's upwards. Right. This is the vertical one, and the horizontal one, it's T2 x is equal to T cos theta is equal to 245 cos 30 degrees. Now let's say 245 cos 30 degrees. It's 212,176 newtons. What is the direction? Direction of that is going to the right. It's going to the right. This one is going to the right. Now we're done with the 2.2.1. 2.2.2, calculate the magnitude of T1. We are looking for T1. It's this force. It's T1, guys. Since this is at it's at equilibrium. Since this is at equilibrium, so we have since it's at equilibrium, these two, so we have this force and this force. So since it's at equilibrium, the magnitude of this force and the magnitude of this force, they're equivalent. But we can prove it by saying, since this is stationary, we can say F net is equal to 0. So we'll choose right as positive. So between the two forces here, these two forces here, so the force of we'll say T2x is positive minus force of T1 equal to 0. So T1 is equal to T2x. They're equivalent, those two forces. This is what I was proving by that. So the T1 is equivalent to T2x, and we have calculated the T2x. It's going to be that, so it's going to be 212,176 newtons. So this force T1 is equivalent to this force is 212,76. Let's go to the last question, 2.2.3. It says calculate the mass M on the crate. So calculating mass M on the crate, so we have to use the trig ratio. So from this diagram, so what are we going to use here in order to get the mass? The mass, we get it by gravitational force. So can't we use the trig ratio like 10 theta that says 10 theta, it's opposite over adjacent. So we'll say opposite over adjacent. So the opposite over adjacent, so we'll use 10 theta is equal to opposite. What is our opposite there? It's FG. And what is our adjacent there? It's T1 divided by T1. So the angle there, it's tan 30. Yes. And the FG, it's going to be M times 9.8. And then T1, we do have T1 here. So it's going to be 212,176, and then we cross multiply. So we're going to have 1.9.8 M is equal to 10 30 times 212,176, and we divide by 9.8 both sides. So our M, when you punch that in the calculator, it will give you 12. It's 12.5